Hello students, welcome back to the last video of this playlist. So this is the 8th video of this playlist. So in this video we will be solving the last question of this P4 June 2023 paper. So basically this question paper has 8 questions. So we have done the 7 questions from 1 to 7 in the previous videos of this playlist, and this is the last video. In this video we will be doing question number 8 from this paper. So let's see what's the question number 8 is about in this paper. So basically, if I give a short review about this question right at the beginning, it's about parametric equations, like workings with parametric equations, and you should have concepts about differentiation of parametric equations and integration of what parametric equations. At the same time, integration by substitution and integration to find the volume under revolution. These are all combined. So if I tell, like, in order to be able to solve this question number 8, definitely you have practiced questions from differentiation, definitely differentiation of partial fractions, parametric equations, and then definitely you have done integration of parametric equation by substitution method, and then like integration to find the volume under revolution. So basically these concepts are discussed in chapter number 5 and 6 of your P4 textbook. So definitely before doing this question you should have practiced enough questions from these chapters. So let's get started. Number 8. In number 8 you can see there is a figure. There is a figure of a parametric curve, basically curve C, and there is a straight line L. You can say, I think this is a normal. The line L, yeah, the line is L is a normal. Okay, fine, we will see it soon. Figure 2 shows a sketch of part of the curve C with parametric equation x equals to t plus 1 over t and y equals to t minus 1 over t, where t greater than what, 0.7. Okay, the curve C intersects the x-axis at the point Q. It intersects the x-axis at point what, Q. What is point Q there? This is the point Q. Okay, we can see here point Q is there. Find the x coordinate of Q. X coordinate. How can we find out the x coordinate? We know that at the point Q, the value for y, whenever a curve or a line crosses the x-axis or intersects the x-axis, the y value is what? 0. So what we will do here is that we will consider what at Q, what we know. We know that y equals what? 0, right? Y equals to 0. So what we can write? So use the parameter of y, t minus 1 over t equals to what? 0. From there what we can write? We can multiply both sides by t, so it will become t square minus 1 equals to 0. So you will get the possible values for t, that is t equals to what? Plus minus 1. But they have given a limit for t, that is t greater than 0.7. So in that case t equals to what? T equals to 1. Okay, if t equals to 1, then x equals to what? Just put t equals to 1 into the parameter of x, that is 1 plus 1, that is 2. So x coordinate of point Q is what? 2. That's it. Next, part B. The line L is the normal to C at the point P as shown in figure 2. You can see in figure 2, right? Line L is intersecting the curve at point P. So given that t equals to 2 at point P, write down the coordinates of point P. We need to write the coordinates of point P. That's pretty easy. Just plug in the coordinates. Just plug in the value for the parameter, that is t, into the equation. You will get the coordinates very easily. What? T is 2. So 2 plus half. 2 plus half, that is what? 2.5. The x coordinate is 2.5. That is p. It is what? 5 over 2. And the y coordinate is 2 minus half, that is 1.5. That is 3 over 2. Fine. Okay, that's the coordinates, x and y coordinate of point P. Next, part C. Use calculus. We need to use calculus to show that an equation of line L is 3x plus 5y equals to 15. They have said here we need to use calculus. Calculus means here for finding the equation of line L, definitely we need what? The gradient. So to find out the gradient, definitely we need what? We need to use differentiation of parametric equations, right? So let's see. We need to differentiate the parametric equations, and then we need to find out the derivative of the curve C to get the gradient at the point P. So if we get the gradient at point P, using that gradient we can find what? The gradient of the normal, right? Okay, so x equals to t plus 1 over t. Okay, so at first we need what? The gradient of the curve. For part C, x equals to t plus t inverse, right? And y equals to what? T minus t inverse, if I'm not wrong. T plus and t minus, exactly. Okay, so now differentiate dx over dt. What you will get? 1 minus t inverse 2, and dy over dt, that is what? 1 plus t inverse 2. Fine. Now we need the derivative dy over dx. This is what? Dy over dt, that is 1 plus 1 over t squared over what? 1 minus 1 over t squared. If you want to simplify, you can simplify it by taking LCM. So you get t squared, so that would be t squared plus 1, and at the denominator that would be what? T squared, then t squared minus 1. So it would give you t squared cancels out, so you'll get t squared plus 1 over what? T squared minus 1. That's it. We got the derivative in terms of t. Now at P, we know that the value for t equals to what? 2, isn't it? Isn't it 2? Exactly, it's 2. Okay, so since at P the value for t is 2, so you can get the value for the derivative, that is the gradient of the curve at point P. That is what? 2 square is 5 over 3. That is 5 over 3, right? Okay, so this is the gradient of the tangent at point P to the curve. Now line L is what? Line L is a normal, so that means the gradient for line L would be what? Negative inverse, right? Negative 3 over 5, negative inverse of the gradient of the tangent. So we got the gradient of the normal, that is negative 3 over 5. Now we know the coordinates of point P. Now that's very easy to find out the what? Equation of the straight line L. So that would be what? Y minus y1. What was the y coordinate of point P? That was 3 over 2. Y minus 3 over 2 equals to m negative 3 over 5 m times x minus what? 5 over 2. Right? So that's it. Now just multiply. What we can do here, okay, at first multiply, then we will see what we need to do. Okay, so 3 over 5 x plus what? 5 cancels out, and it will become plus 3 over 2. Now we can multiply both sides by 10. Okay, to cancel out all of the fractions. So you get 15 equals to negative 6x plus 15. So you will get 6x, take all the terms to the left, so 6x plus 10y minus 30 equals to what? 0. If you simplify it more by dividing both sides by 2, what will get? 3x plus, okay, they wanted in which form? They wanted 3x plus 5y equals to 15. Okay, 3x plus 5y, take 30 to the right side, so 30 over 2, that is what? 15. That's it, done. Simple. Okay, next, the last part is part D. What they have asked there: the region R shown shaded in figure 2 is bounded by the curve C, the line L, and the x-axis. Okay, fine. Using algebraic integration, find the exact volume of the solid of revolution, okay, formed when the region R is rotated through 2 pi radians about the x-axis. This is what? Finding the volume under revolution. Okay, fine. So this is integration, like finding the volume under revolution by using what? Integration. Okay, at first let's figure out how to approach this integration. Look at the region R. Region R, it's a bit complex volume. It would be a bit complex because the region R, it is like combined of two equations here, right? Line L and the curve C. So we will divide this region into two parts. At first, the first part would be the volume under revolution of the curve from Q to P. At Q, the value for x is what? 2. And at P, the value for x is what? The value for x is 5 over 2, right? And the second part would be the volume of revolution under the line L. Okay, so we need the point where the line L intersects the x-axis. So let's figure out that at first. Okay, so for part D, at first what we need to find the point where the line L is intersecting the x-axis. Okay, so at x-axis, what we know? Y equals to what? 0, right? Y equals to 0. Okay, so if y equals to 0, then what you will get? X equals to 5. That means the line L intersects the x-axis at x equals to 5. Okay, so now it's time for integration. How we will integrate? We will integrate the curve from 5 over 2 to 2. Okay, like using pi integration of y squared dx, and we will integrate the line L from what? 5 to 5 over 2 using pi y squared dx. Okay, so let's make y subject from this line, equation of the line. What you will get? Y equals to negative 3 over 5 x plus what? 5, right? 15 over 5, that is 3. So negative 3 over 5 x plus 3, isn't it? Negative 3 over 5 x plus 3. So we got the equation of line L. Okay, now it's what? Integration. Volume. So volume would be what? Pi integration for the curve. It is what? From P to Q. Point P is 5 over 2, and point Q is what? 2. Okay, y square dx plus pi times integration for the line L, for the volume of revolution under line L. It would be from 5 to 5 over 2, and the equation was what? Negative 3 over 5 x plus 3 whole squared, isn't it? Whole square dx. Let me check. Negative 3 over 5 x, negative 3 over 5 x plus 3. Exactly, negative 3 over 5 x plus 3 whole squared. Okay, now let's do the integrations separately so that you can do the workings comfortably. Okay, so at first, integration from 5 over 2 okay, integration y squared dx. Y squared dx can be written as what? Look, y square. We will make all the y and dx in terms of t. Okay, so for y squared, we know that we know the parameter for y, that is 1 plus 1 over t, right? 1 over t whole square, and in place of dx, let me check the y parameter. It's t minus 1 over t. Okay, it's t minus what? 1 over t. Okay, that is just t minus 1 over t. Okay, t minus 1 over t. Fine. So t minus 1 over t whole squared dx. So in place of dx, we need to make it in terms of t. So use the x parameter. X equals to what? T plus t inverse, right? So dx over dt would be what? 1 minus what? T inverse 2. So what we can write? Make dx subject. You will get 1 minus 1. Is it 1? Yeah, 1 over 1 minus 1 over t squared dt. So we got the substitute for dx, so we will just put it here. So what you will get? 1 minus 1 over t squared times what? dt. Fine. Now the limits. We need the limits for t now, because the previous 5 over 2 and 2 are the limits for x. So for t, the limits would be the values for t. What was the values for t? We got at point P, they said the value for t is what? 2. So at point P, that is t equals to what? 2. And at point Q, the value for t is what? 1. Right? We got this in part A. T equals to what? 1. Okay. So that means the limit, the upper limit would be 2 and the lower limit would be 1. That's it. So we got all the terms in terms of all the whole integral in terms of what? T. Now it's time to expand that. How can we expand it? T minus 1 over t. It can be written as what? A square minus 2ab plus b squared 1 over t squared times what? Times 1 minus 1 over t squared dt. Okay. Now what we can do? We can expand the brackets. So you'll get t squared negative 1 negative 2 plus 2 over t squared and then plus 1 over t squared plus 1 over t squared, and then what we will get? We will get 1 over t squared times plus 1 over t squared times negative 1 over t squared. That would give you negative 1 over t to the power 4 dt. This is the expanded form. Right? Now what's our work? Do the manipulation. What you will get? 2 to 1 t squared. Are there any t squared? No, just t squared, then plus 2 over t squared plus 1 over t squared, that is 3 over t squared, that is 3 t inverse 2, negative 1 negative 2, that is negative 3, so negative t inverse 4 and then negative 3. Okay, fair enough. Next is just to integrate within the what? Definite integral. So you'll get t cube over 3 and then you will get minus what? Why it is minus? Because t inverse 2 minus 2 plus 1, that is negative 1. So plus 3 over negative 1, that is what? Negative 3. And you will get here t inverse 3. Okay, so minus 1 over minus 3, that is plus 1 over 3 minus 3t. Upper limit is 2, lower limit is what? 1. This is the integration within the what? Definite integral. Fine. Now your work is just to put the values for t into the definite integral. So 8 over t3 minus what? 3t inverse 1. So it would be 3 over 2, right? plus 1 over t cube. 2 cube is 8, so 8 times 3, that is what? 24, minus 6, and then minus 1 over 3 plus 3 over 1, right? So that is 3, just 3, and then minus 1 over 3, just substituting the lower limit 1 into the integral, and then you'll get plus 3, right? So 8 over 3 minus 3 over 2 plus 1 over 24, negative 6, and then negative 1/3 plus 3 plus 1/3 minus 1/3 plus 3. Oh, it should be what? Oh, it was t inverse 4, right? Since it was t inverse 4, so as you integrate, it will become positive. Okay, it's positive there. So what we will get here? Okay, so we will get 8 over 3 negative. Is this fine? Negative 6. Where we got negative 6? Okay, negative 6 comes from here. So negative 1/3 plus 3. Okay, 3 over 1 is 3. That's fine. And then negative 1 over 3 plus 3. Okay, that's perfect. Okay, so do the calculation. Negative 6 plus 3. Okay, plus 3 plus 3, that is 6. 6 minus 6, that is 0. Now do the calculation with the fractions only. 8 over 3 minus 3 over 2 plus 1 over 24, negative 1/3, and then what's there? Negative 1/3 again, and that's it. So we'll get 13 over 24. That is 13 over 24. So we got the integral, the value for the integral, right? Integration of y squared dx. Now we need to integrate this part, right? So if you integrate this part, what you will get? If you integrate this part, you will get pi y squared dx. Okay, we can consider one thing here. Okay, what we can consider here? Look, consider the volume under the straight line L. Okay, it is basically it's forming a cone, right? It's forming a cone like this with a what? Circular base, isn't it? With a cross section, like the base is what? Circular. This is basically circular. Okay, because consider this point, that point, right? And this is the circular base. So basically you can use here the area, the volume of a right circular cone. It is basically a right circular cone. What's the volume of a right circular cone? That is 1 over 3 pi r squared L. Pi r squared L. What is L there? L is basic pi r squared h, not L. L comes for area. Okay, surface area. 1 over 3 pi r squared h. H is basically the height. Okay, so in that case, what would be the height? That's pretty easy to understand. The height is what? From x equals to 5 to x equals to 5 over 2. That means the height is h equals to 5 over 2. That's it. So rather than doing this long integration, we can find out the volume under the line directly, as it will form a right circular what? Cone. So let's do that. Volume, let's consider the equation, like the equation for the volume. We got pi times integration, right? Integration of y square. Since we got the integration of this part already, so this is what? Just we got 13 over 24. So that is what? 13 over 24. Fine. This is the volume under the curve, plus 1 over 3 pi what? R squared. R squared is what? R is basically 5 minus 5 over 2, that is like 2.5. So 5 over 2 whole squared, and then h. Height is how much? Okay, wait, I did a mistake. Height is 5 over 2. That's fine. Height is 5 over 2, and the radius is how much? Radius is basically, I didn't show you the radius. See the like the radius of the base. Basically this is the radius, right? This is the radius r. So this r is basically the height of the point P from the x-axis. What's that? It's basically how much? What was the y coordinate of point P? We got 3/2. So the radius is what? The radius is 3/2 units. That's it. Okay, so we got the radius 3/2 whole squared. Now you just need to do the calculations. You will get 13/24 pi plus 3 square is 9/2. So do the calculations. 9/4. 9/4 times 5/2, that is 45/8. So 45/8 times 1/3. So what you will get? Okay, we'll get 15/8. That is 15/8 pi radian unit cube. So now add them up. So what you will get? 15/8 plus 13/24. So that is 29/12. 29/12 pi unit cube, since it is volume, and that's the answer. Right? Now the question is, if we had done this whole integration, it would take so large time, right? For 7 marks, it's not worthy. It would not be worthy to do the whole like 2 integration in one of the question, in only one question for 7 marks. So like for this type of questions, if there is any like regular shape you can figure out from the volume, then use the equation for finding volume of the regular shape to find out the volume in an efficient way. Like as we have considered the right circular cone, it becomes so easy that you can even find out the volume just within a minute. So I hope you understood this question very well, and that was all about the whole question paper, since this is the last video. That is June 2023 P4 paper, and yeah, that's all about this paper. Thank you.